get into the concept now. Maximum speed. M3 will acquire maximum speed when something that two masses, our masses can be related here. Is it possible? Something equation of this kind can we bring? Okay, first collision will occur. After first collision, we'll see what conditions will come. Clone, so there's a first collision. So this will be second. I think I am going to show all the description, at least after seeing this, try to work out. So this was the test. So after collision, this will start moving with certain velocity, say V1. This will be V2. Still, this will be a test. This is moving with the velocity, let it move with its own velocity, we are not bothered. This will go in collide. After collision, this will acquire speed V2. This is V3. So this will be V2 dash. M3 will acquire maximum speed. I think that was the condition that is asked. So let me apply the conservation of linear momentum. I think that's the only thing which will help us a lot. Look at all the collisions are perfectly elastic. I think this word is also very important. So first I'll use M1U equal to M1V1 plus M2V2. Then applying quotient of restitution formula, V2 minus V1 by U minus 0. Perfect elastic collision equal to 1. So V2 minus V1 is equal to U. Let me eliminate V1 because V2 is what needed to carry on the problem. So V2 minus U equal to V1. So M1U equal to M1. If you know directly that formula, better 2M1. If you better remember that formulas will be very useful. Okay, this will go in collide. So again, let me apply conservation of linear momentum between this. M2 V2 is equal to M2 V2 dash plus M3 V3. M3 will acquire something velocity of V3 is what needed for us. So this will be M2, applying conservation of linear momentum again. V3 dash, V3 minus V2 dash by V2 0. So as E equal to 1. So therefore V2 equal to V3 minus V2 dash. Let me eliminate V2 dash from here. V2 dash will become V3 minus V2. Or else you could have used the same formula, what we had earlier. 2M2 V2 by, no need to solve. You could have used same formula, just replace M1 M2 by M2 M3 and U by V2. Please do remember at least this formula now. This V2 value, let me substitute that M2 by M2 plus M3. This will become 2M1U by M1 plus M2. So 2, 4 M1 M2U by M3 will acquire maximum speed when M2 is equal to, what shall I do here? Clear? Okay. How to bring that mathematical condition here? V3, when it will be maximum, it all depends upon the value of M2. So let me differentiate this with respect to M2. V3, the equation that I'll differentiate with respect to M2, then I'll solve it. I'll get certain condition. So then I can go further. So this differentiating with respect to M2 dV3 by dM2, and I'll equate to 0. So if you look at the advanced, we don't have any numerical till now related to numericals of this kind. You be careful. Possibility of asking conditions of this. This will be your answer. Check it. Maximum focus on the numericals which you have some new ideas, like here in the collisions we did so many problems, like the maximum speed of the particle of the ball or the sphere 3 depends upon the what mass you pick up of the second one. So I think like this, the collisions know if they really want to, they can go for up to these level also. I have another some good number of numericals are there. So I think there's so tomorrow I'll continue from here. Tomorrow we'll bring the other numericals also. I think almost I'm bringing all this week's syllabus. Tomorrow we'll explore a few more numericals.